Okay, we're going to look at the surface area and volume of the rectangular prism by the piece-by-piece method, taking each face and finding the area individually, then adding them up, or by using the formula. So here we have a beautiful rectangular prism, and we're going to start with the surface area, and we're going to go section by section. If we take a look at the net of this figure, this is a better idea of what we have if it's flattened out. Now, nobody's going to flatten it out on a quiz or a test, but what you're going to have to do is kind of go through this and see what the area of each face is. Now, they're all going to be rectangles, so that's pretty easy because all you're going to have to do is length times width. So let's take a look at each piece. The bottom here is 2 by 3. Okay, this is 2. This is also going to be 2 by 3, and you can actually get a better figure, I think, in the three-dimensional version of this. Now the opposite faces are going to be exactly the same, so I don't have to really worry about the top. It's going to be exactly the same as the bottom. This would be actually the back of the figure or the front, depending, but if you can see here, this is 3. I got that from up here, and the height here is 6. So 6 times 3 is 18 square centimeters. That's the area of the back. Again, the front's going to be exactly the same, so that's this section, or 3 by 6. You can see that 6 actually is found 4 places in this diagram. The 12 there is, this would be the right side, 2 by 6, which is 12, and left side, like I said before, is going to be exactly the same. So all we have to do is add those up, and we get the surface area of 72 square centimeters. Again, surface area in square units. We would actually, if we wanted to cover this in square stickers that were 1 centimeter by 1 centimeter, we would need exactly 72 of them. So we're measuring in squares. Formula wise, you can see the formula down here. One thing I like to do before I do this is make sure I know what my length, height, and width are. One common mistake is some kids thought that this was a 1. It's not a 1, it's an L. Okay, we wouldn't put times 1 in a formula because you're just going to get the same thing back. And you can see also here in the diagram, this isn't a 1, it's a length. So I like to go in and I like to actually go in and label. So I know that's my length going across the front. The width here is going from front to back. And my height is going to be actually how tall the figure it is. And it can be found in 4 places, not specifically here because there's an H here. Okay, they're actually, this line here is actually the same as this line and this dotted line in the back. So now I'm going to take the formula and I'm going to plug in. You can see it's a lot easier if you have these all labeled. You don't have to keep on going back to this diagram, then to that diagram. You can just kind of take a look at where my W is. Here it is. So 2 times the width, which is 2. The length is 3. Then plus 2 times the length, which is 3. The height, which is 6. Plus 2 times the width, which is 2, times the height, which is 6. I'm going to follow order of operations. Multiply everything out here. And a lot of calculators, you can just pop this whole thing in. Just make sure before you decide to just pop the whole thing in. But most scientific calculators aren't going to give you a problem. Add these together, and we have our surface area 72 square centimeters, exactly like you have in the piece-by-piece method. What I like the piece-by-piece method is if this is, let's say, some sort of container and they don't have a top to it, you would not find the area of the top. Let's say you were painting the figure and it didn't have a top, you're not going to paint the top. But also that becomes a different problem because then you have an inside surface area as well. So we're just kind of treating the figure as a whole here and doing the painting the outside. Again, I'm just labeling these pieces. And we're going to use the formula length times width times height to find the volume. Probably this is the, anytime I ask for a formula, this is what people usually yell out. So 3 times 2 times 6, we get 36 cubic centimeters, and it is a measure in cubes. If we had a cube that was 1 centimeter by 1 centimeter by 1 centimeter, we'd be able to fit exactly 36 inside here. So it's really a measurement of the three-dimensional space it takes up, so it should have three-dimensional units. So that's it for the surface area and volume of a rectangular prism. Hope it helped.